area, or you can also say superficial expansion. As the name suggests, area. In area, we are going to take a thin sheet which is having the length, which is having the breadth also. So whenever we are having the solid in a form of thin sheet, then on heating this thin sheet, there is an increase in the surface area of this material. So this increase in the surface area of this material or this solid is known as area or superficial expansion. So the amount of area or superficial expansion is also going to depend upon the three factors. What are that three factors? That is original area, then we are having rise in temperature, then we are having nature of the solid material. Whatsoever expansion we are going to study in this chapter, either it will be linear expansion, area or superficial expansion, or third we are having the volume expansion. In each and every case, we are going to just say that all these expansion are going to depend upon three factors. That three factors are original length, original area or original volume you can say, and second there is a rise in temperature, and third there is a nature of the material used. Okay. So as we have discussed about the coefficient of linear expansion, and coefficient of linear expansion is what? It is alpha. Okay. And now we are going to discuss about the coefficient of the superficial expansion, that is area expansion. So see carefully. For example, here I am having a thin sheet which is having some its length, some its breadth. Okay. So after giving the heat, there is an increase in the area of the solid. Obviously, there is a thermal expansion of the solid also. Firstly, let us say that original area of the solid is A, and after taking the heat, the change in the area is delta A. And whatsoever change in temperature is there, that change in temperature is delta T. Now see carefully, whatsoever there is a change in area, that change in area is directly proportional or going to depend upon two factors. That is firstly the original area, that is A, and it is also going to depend upon the whatsoever change in temperature is there. Means delta A or change in area is directly proportional to original area and what is the change in temperature. But in numericals we are not going to use directly proportional sign, or in any case we are not using that much directly proportional sign. We are always using the is equal to sign. So here also I am going to convert the directly proportional to is equal to sign. So delta A is as such, instead of directly proportional I am going to use here is equal to. But yes, in order to convert the directly into the is equal to sign, I have to use one coefficient or use one constant, and here in this case of the superficial expansion I am going to use one different coefficient or the different constant. That constant is known as beta. Beta is what? Beta is nothing but the coefficient of superficial expansion. Next, A delta T is as such. Now I am going to define that what is beta, what is coefficient of the area expansion. See carefully, delta A is as such over A delta T. A delta T is as such is equals to beta. Okay. Now what is beta, or what is the coefficient of area expansion? Coefficient of the area expansion is defined as change in area per unit original area per degree rise in the temperature. So by watching the formula only you can just write the definition also. Okay. So next we are having its SI unit. As we know, beta or coefficient of superficial expansion is beta, that is delta A over A delta T. Okay. Now just put the SI unit of the area and temperature. What is the SI unit of area? SI unit of area is meter square over SI unit of area again is meter square. Delta T means change in temperature. Temperature SI unit is Kelvin. Okay. Now meter square cut with meter square, what you are left with? You are left with 1 over Kelvin. So 1 over Kelvin is nothing but per Kelvin. So what is the SI unit of coefficient of area expansion? SI unit is per Kelvin, same as the coefficient of the linear expansion. Means the coefficient of linear expansion, SI unit of coefficient of linear expansion, SI unit of coefficient of superficial expansion, as well as SI unit of the volume expansion, they all are same only, that is per Kelvin. SI unit of alpha, beta, and in the volume expansion you will say that it is gamma. Okay, this is a linear expansion, this is area expansion, and this is volume expansion. All the SI units are same only, that is per Kelvin. And whatever other unit we are using, other unit is per degree Celsius. So next topic we are having relation between coefficient of linear expansion and coefficient of superficial expansion. As you know, coefficient of linear expansion is nothing but alpha and coefficient of superficial expansion is beta. Now we are going to see the relation between alpha and beta. So relation is like this: beta or coefficient of superficial expansion is equals to twice of coefficient of linear expansion, that is beta is equals to 2 alpha. And now how this relation came, that you will do in the higher classes. Okay. So here we are having the definition of this relation between alpha and beta. For a given material, the value of coefficient of superficial expansion is equal to twice of the value of coefficient of linear expansion of that material. Okay, this is the relation between alpha and beta.